All right, guys, we're here to wrap up the second day of dealing with inverse relations and functions. Again, remember, we're just trying to get some more challenging examples like it says here. And we're going to find the inverse. Remember, f of x is the same thing as y. So I get x equals the square root of y plus 3. All right, so some things we're going to do is we're going to square both sides. So I get x squared equals y plus 3. And then we just need to get rid of that 3, so minus 3. So we come back to saying y equals x squared minus 3. Remember, we're going to change the notation just a little bit. So it's the function, right? F to the negative first power of x equals x squared minus 3. Not too shabby. All right, so we have the same thing going on here. Instead of the square, it looks like a cube root this time instead of a square root. So we get x equals the cube root of y plus 1. So what are we going to do? We're going to have to cube it to free up this cube root. So x cubed, I'm going to leave a little space this time, y plus 1. So subtract the 1, there it goes. So here's what we have, but again, we want to change the notation. So g to the negative first power equals x cubed minus 1, and that gives us our inverse function. All right, the next two are going to have a little bit of a challenge to them because as we change things out, notice what happens is I have two of them. So we're going to present this a little bit different. We're going to cross multiply. And while I do this, I'm going to distribute it. So I get xy minus 3x equals y plus 1, because times 1 is going to leave me with just that. We're trying to solve for y, remember? So what I want to do is subtract y to this side and add 3x to that side. You'll see why in just a second. So I get xy minus y equals 3x plus 1. And what I've created over here is a GCF of y. So I have to make this y, and then x minus y divided by y is 1. Now I can divide by x minus 1 to get my inverse. And that takes care of the whole thing. So the inverse function of x should be 3x plus 1 over top of x minus 1. All right, so we dealt with these in the fact that if I have multiple of the same variable that I'm trying to solve for, I need to get them on the same side like we did way down here so I can take it out as a GCF. Okay, that's going to be our strategy if you have multiple of the same variable that we're trying to solve for. So here it is again. X equals 3y plus 1, y minus 5. All right, so we're going to make this over 1, cross multiply. I am going to, again, distribute while we do that. So I have xy minus 5y, nope, 5x equals 3y plus 1. We're going to move some terms around. So I get xy minus 3y equals 5x plus 1. Right? We added 5x. Now we created the same situation. So here it is again. I have a GCF of y, and then I have x minus 3 left over equals 5x plus 1. So that's the thing we're going to divide, is 3x, or x minus 3. All right, and this wasn't just plain old y. We're going to change that to g to the negative first power. So now we have 5x plus 1 over top of x minus 3. All right, so that's what we're after. All right, so we stepped it up just a little bit. Right, but both C and D are both along the same lines. We want to make sure if we had multiple of the y variable we're solving for, we got to put them on the same side so they become a GCF. All right, composition time. That means we're going to plug one of these into the other. So let's start here and here. So that's the first thing I'm going to do is plug that value in. So I have the square root of x squared minus 3 plus 3. All right, well, this one's not too bad because a minus 3 plus 3, they cancel each other out. And then I have the square and the square root, so I get plain old x. Right, so I didn't show much work there, but that's just the way that one is. All right, now let's work the other way. So let me erase my highlighting here. So this time we're going to take this whole square root of x plus 3 and put it in right there just for x. So I need the square root of x plus 3 squared and then minus 3. Well, the square and the square root cancel each other out. And the 3 and the negative 3 cancel each other out. All right, so they both turned into x. So are they inverses? Yes. Okay, or we'd say that they are inverses, or however you want to note it, right? Maybe we say the inverse of x equals g of x, right? Because they are inverses. All right, and the other one, oh boy, we got some fractions all over the place. So let me start first by highlighting, and we'll work the same way as we did last time. So I'm going to take this and I have to put it here and here, and I'm going to have fraction within a fraction. So this is going to be a complex fraction over top of 1 over x minus 1. Okay, let's see what we can do with this. It's a division problem, but it's written vertically, so that becomes a little more challenging. So let's see, what do you think? Let's clean up the top maybe. Okay, and now let's go ahead and divide. Okay, so 1 over x minus 1 plus 1, right? It is divided by 1 over x minus 1. So all I did is I took this vertical representation, wrote it horizontally. So the next thing I'm going to do is 1 over x minus 1 plus 1 times x minus 1 over 1. Okay, so that means I need to multiply this whole thing. So I'm going to multiply here and here. So if I make this x minus 1 over top of x minus 1, I get 1. And then when I multiply here, I'm going to get plus x minus 1. Well, here my positive 1 and negative 1 cancel each other out, so I do get x. So we're halfway through, and we had a lot of fractional things to deal with. All right, so I'm going to have to scroll over and get a little more space here. All right, so we went this way. So this time I want to take this fraction here and only put it in one place. I don't know if that's going to make this easier or harder. So let's see what happens. Purple. I like purple. All right, 1 over x plus 1 over x, and then minus 1. Okay, so let's see if we can just clean up the bottom by making this a common denominator. So this is 1x plus 1 over x minus x over x. So now this isn't as complex on the bottom. So that means I have x plus 1 minus x over top of x, right? So all I did was made this into one big fraction, putting this negative up here. All right, so I have x minus x. All right, so now I have 1 over x. So that's 1 divided by 1 over x, which means I need 1 times x over 1. Well, look at that. We get plain old x out of this whole thing. All right, so both of these, they had these complex fractions in them. So really the idea here was I wanted to try and clean up the entire denominator first for this one by making a common denominator, cleaning the whole thing up, and then finally dealing with the complex fraction. Same thing happened here. Well, it could have, but I kind of saw what was going to happen. So the strategy here was go ahead and flip it so I can distribute, because I know these were going to cancel out into the 1 that I wanted, and this was going to give me the x minus 1. Okay, but I could have done the same thing. I could have worked through the top right here and made myself one fraction out of this by using this x over x idea, because that is the same thing as 1. So we have a couple different ways about that. As long as we don't break any mathematical rules, then it's okay. And if we have questions about that, we'll continue to work on that in class. All right, otherwise we do have a few homework problems. We can give that a try. And we'll catch up in class.